What is epigenetics and how does it affect the brain? Imagine your genes are like a set of instructions for building a house. Epigenetics is the way your environment and experiences can turn those instructions on or off without changing the actual blueprint. It's like flipping switches that control how genes work. This process is especially important in the brain, where it influences how neurons develop, connect, and adapt over time. Epigenetics involves mechanisms such as DNA methylation, where chemical groups are added to the DNA. This usually suppresses gene activity. Then there are histone modifications, which are changes to proteins called histones that DNA wraps around. These modifications can either make genes more active or quieter, depending on the type of change. Think of it like adjusting volume knobs on a stereo to control how loud or soft the music plays. During early brain development, epigenetics guides how neurons form, migrate, and specialize. These changes help shape the brain's wiring, influencing learning and behavior. Once neurons are formed, epigenetic marks help keep their identity intact, even as the brain continues to grow and change. This means that the brain's structure and function are partly written by these chemical switches. Epigenetics also plays a role in how the brain adapts to new information. When you learn something new, epigenetic marks can change to support memory formation. These stable changes in gene activity help keep memories long-lasting. The brain's ability to respond to its environment depends on these epigenetic adjustments, which can be influenced by factors like stress, nutrition, and caregiving. In early childhood, epigenetics acts as a bridge between your genes and your environment. Positive experiences like nurturing and proper nutrition can promote beneficial epigenetic changes that support healthy brain growth. Conversely, stressful or adverse conditions might lead to changes linked to developmental challenges. This shows how important early life is for setting the stage for lifelong brain health. Understanding epigenetics in the infant brain highlights how sensitive early development is to external influences. It also opens doors to potential interventions that could modify epigenetic patterns, helping to support better cognitive and emotional outcomes. Researchers are exploring ways to use this knowledge to help children with neurodevelopmental disorders or those who face early life stress. In essence, epigenetics is a way the environment can shape gene activity without changing the genetic code itself. It is a key player in brain development, learning, memory, and adaptation. During the rapid growth of infancy and early childhood, epigenetic changes are especially active, making this a critical period for shaping the brain's future.